Hello, beta. Good afternoon. How are you?
Good afternoon, sir.
Good afternoon. The recording of the session is on now. So let's continue with our discussion. Yesterday we did the PZX triangle. So let me show you in the presentation. So today we are going to apply the concept of PZX triangle to solve the questions based on star identification. So let's first get a recap of the PZX and then we move on to these star identification questions. So let me open up the PPT. So beta, this was what we did yesterday. So any doubt or any clarifications in this diagram, PZX diagram, any doubts you are having, you can ask me. Okay, very good. So that tells me no doubt everything is okay. So shall we proceed on to star identification?
Yes, sir.
Okay, great. So let's move into the topic of star identification. First, we will see what this topic actually is. What is the need of identifying the stars? And then we will see how we can use the concept of the rational horizon diagram or the PZX triangle to identify them. So let's continue. In this presentation, we are going to learn the identification of stars for the purpose of site taking. Let's first understand what is the need and purpose of star identification. Now we have been working out the sites to fix up or find the position of the ship. We use various celestial bodies for working out the sites. The sun, the planets, Venus, Mars, Jupiter, and Saturn, the 4 planets are used for celestial navigation, the moon, and the stars. Now, when we use the stars for site taking, for fixing up our position, one important thing which is involved in the process is the identification of the star. When we go out to take a site and we observe a particular star, we take its altitude, we take its azimuth, and then we come inside to work out that site. Now, for working out the star site, we need to identify the star whose altitude or whose site has been taken. This is required because we need to get the almanac data for that particular star, that is its SHA and declination. It has to be picked up from the almanac. Then only the site can be solved. So to obtain this information from the almanac, we need to identify which star is this, which we have used for taking our site. Now, practically it is done on board a ship using a star finder. You can see a star finder on the screen right now. This star finder has a base template. There are two base templates basically, one for the northern hemisphere, other one for the southern hemisphere. And on this base template, we place transparencies. There are different transparent sheets basis different DR latitudes. And once you place this transparency, you align it with the base template using the LHA of Aries. So LHA of Aries is calculated for that particular time when site is taken. And when the LHA Aries is aligned with the base template, you are able to see all the important stars which are there in your view, or which you can observe and use them for site solving. So you will get approximate altitudes and approximate bearings or azimuth of all those stars. So this helps you to identify which is the star which you have used for your site taking. Now, as the technology has grown up, we now have various free applications which are available on our smartphones also. Google Sky Map is one of these applications. You can see these applications on the Play Store, and you can easily use them to identify the stars. So this is what is practically done on board a ship, and this is what is the need and purpose of star identification. Now, when this question comes in our exams related to star identification, we are not given a star finder, nor we have access to our phones. So for examination purpose, we will need to identify the star using the almanac information only. So we are now going to see how to identify a particular star which has been used by the navigator for site taking using the almanac data. This is done using the rational horizon diagram. So use the rational horizon diagram, or the diagram of the celestial sphere made on the plane of the rational horizon, to solve these type of questions. Now, when we use the rational horizon diagram for identifying a star, the basic concept which is used is that we fill up all the given information to us. Whatever information is provided to us in the question, all that information is filled up in the rational horizon diagram. Now, once you fill that up, the rational horizon diagram will give you the PZX triangle. So
इसमें वो definition निकाल के करते हैं sir.
And some of its parts are known. PZX triangle is a spherical triangle. So we can apply the spherical trigonometry formula, like the cosine formula or the Napier's rule, whichever is applicable in a particular situation. We can apply these formulas, and using them, we are able to easily identify the star.
सर इसमें declination निकाल के करते हैं sir. Like declination निकाल लो तो star का मिल जाता है, वही है sir ये?
Yeah, that's right, beta. We find the declination. Not only the declination, we find two things basically: declination and the SHA. Sidereal R angle, SHA and the declination. इन दोनों को हम लोग find करते हैं. And once these two are known, then we can use the almanac to identify which star is the one for which we have observed or we have taken the site.
Okay, sir. Okay, sir.
Okay. Okay. Any more doubts up to here, beta? Okay. All right. So this is the basic concept which we use in star identification. Now, we can leave these concepts for the time being. We can straight away move to the procedure. Now, having understood the basic concepts related to a star site, let's now see the procedure, the method which we use to identify an unknown star. Now, in these type of questions, the information which is available to us is the date and time of the observation is provided to us. The DR position of the observer is provided to us. The sextant altitude and along with it the index error of the sextant and the height of eye of the observer is also given to us. The index error and height of eye is required to correct the sextant altitude and obtain the true altitude of the star. Now, along with it, the bearing or azimuth of the star is also provided. Now, if you look carefully, all this information is available to you when you take a star site. You can visualize, let's say it's a evening twilight time and you plan to take a site. You just go outside on the bridge wing, see a particular star, take its altitude and come back. You know what is the date and time. You also know what is the DR position of the ship. Even if GPS is not there, we are assuming in all these questions that GPS positioning is not available to us. The DR position is still available. DR position is obtained using the course steered and the engine distance steamed. So engine distance is available to us from the log. The course steered is available to us from the gyro compass. The sextant altitude of the body of the star is taken. So we are aware what is the sextant altitude. We know the index error of the instrument of the sextant. The height of eye of the observer is also known to us. When we take a star site, we take the bearing or the azimuth of the star. So this is also known to us. So all this information which is available to us in these questions is known to the navigator when he takes a star site. Now, what we are required to do is we are required to identify the star used in the site. So let me give you a practical example of a question based on star identification. So we will have a practical question with us, and we will use the rational horizon diagram to find the method or procedure, understand the method or procedure with which star can be identified. So we have an example now on the screen. On 30th April 1992, you see the date and time is given to you at GMT 20 hours 51 minute 23 seconds. In DR position 30 degree 15 minutes north, 040 degrees 20 minute west. You see the DR position is also given to you. The sextant altitude of an unknown star bearing 285 was 35 degree 10 minutes. Index error is 2 minutes of the arc and height of eye is 15 meters. So just to correlate, you see the sextant altitude is given to you. The index error of the instrument is given to you. The height of eye is also provided to you. The bearing or the azimuth of the star is also provided. And we are required to identify the unknown star. So let's try to pick up this question and solve it using the rational horizon diagram. Beta, any doubt up to here? Any doubt in the question, in the information? Okay, great. So shall we proceed ahead?
Yes, sir. Sir, ये second mates में नहीं आते थे ना question? नया है ना?
बेटा second mates में भी कभी-कभी, not very frequent, but yeah, practical is not there in second mates. Only the theory part is there. Practical is not there.
और sir अभी आते ही वाले exam में?
Yes, phase 1 exam you can have one of these questions coming in.
Okay, sir.
It can come in question number 7 of your paper, beta. Part C जो पेपर का है हमारे, उसमें जो फर्स्ट क्वेश्चन है, that's question number 7. It could be based on this topic. It is based on one of the two topics. One is star identification, other is star suitable for sight. So इन्हीं दोनों में से एक टॉपिक पे हमारा क्वेश्चन नंबर 7 आता है. So star identification is what we are covering now, and stars suitable for sight I will cover a little later after we have done the sights. So उसके बाद मैं आपके साथ suitable stars भी cover कर लूँगा. So this comes in phase 1.
Okay, sir.
Okay, all right. So let's proceed ahead. So once again, I'm just noting down the information available so that it's there on the screen and you can see it all the time. The information available to us, the date and time, DR position, sextant altitude with index error and height of eye, the bearing or azimuth of the star, and this is the question which we are looking at. So let's now try to put this information, fill up this information in the rational horizon diagram. The basic concept, the basic approach in these questions, as I told you, is to pick up all the information and fill it up or put it in the rational horizon diagram. Once you put it in the rational horizon diagram, you will be able to see what all methods can be used, how spherical trigonometry can be used to identify the star. So let's draw the rational horizon diagram. Now we are aware in the rational horizon diagram, at the center we have the zenith of the observer. The circumference represents the rational horizon of the observer. And you see these 4 points representing the directions. Right on top, you have the north point. 90 degrees to its right, you have the east point or 090 bearing. Exactly opposite to north, you have the south point or 180 bearing, and 90 degrees to the left of north, you have the west point or 270 bearing. Coming back to north, it completes the 360 degrees of bearing or azimuth, which returns back to 000. So we have the rational horizon diagram. Now let's try to fill up all the information which is given to us in the question. Now the first thing which I pick up from the question is, they have given us the DR latitude 30 degree 15 minutes north. So the observer is in 30 degree 15 minutes north latitude. That tells us that the zenith, which represents the observer's position on the celestial sphere, has to be 30 degree 15 minutes north of the equinoctial, which represents the equator. or you can say the equinoctial has to be 30° 15 minutes south of the zenith in this case. So let's show the equinoctial here. I will first fill up the latitude. You can see the latitude highlighted in red in the diagram. Now the radius of this rational horizon diagram is 90 degrees. How we can understand this radius as 90? You see the zenith is the point which is directly overhead of us, and its altitude is 90 degrees. The rational horizon, on the other hand, is a locus or combination of all the points which are at 0° altitude. So rational horizon represents 0° altitude. The zenith represents 90° altitude. So you can easily visualize the radius of this particular diagram is 90 degrees. So taking that standard, our latitude is 30 degrees, which is approximately 1/3 of the radius. That's why you see this particular length for the latitude has been picked up, approximately 1/3 of the radius. Now this point where the latitude takes us, the other end of the latitude, highlighted red color line, is the Q point. This Q point represents the equinoctial, and we are aware that equinoctial will pass from this Q point, and equinoctial always passes from the east and west points in this diagram. The nature of the diagram is such that whenever you draw the equinoctial, it will always pass from the east and west points. So we now know equinoctial passes from east and west point, also from the Q point. So we can draw the equinoctial now. You can see the equinoctial drawn in the rational horizon diagram represented by WQE. Now, once the equinoctial is identified, we can now draw the pole, the celestial pole. The celestial pole is 90 degrees away from the equinoctial. And whichever hemisphere the observer is in, the same hemisphere's celestial pole will be visible to the observer. So in this case, the observer is in northern hemisphere. So we will have the north celestial pole above our horizon, and it will be 90 degrees from the equinoctial or from the Q point. So from the Q point, you go 90 degrees, and this is where you have the pole. Let's mark it with P. The pole is represented by the alphabet P. So we have the pole in our diagram now. Now we can easily highlight the PZ side. Okay, Papa to Zulu, the segment which is highlighted in yellow now. We know from the concept of PZX triangle that this PZ is the colat of the observer, or 90 minus latitude of the observer. You can easily understand it from here also. We know pole to equinoctial, that is P to Q, is always 90 degrees. Equinoctial is 90 degrees away from the pole. And we know Q to Z or ZQ is the latitude of the observer. So ZQ being the latitude, P to Q being 90 degrees, obviously PZ side comes to be 90 minus latitude, or you can also call it as colat of the observer. Now, the next thing which I am going to plot in the diagram, we know the bearing of the star is 285 degrees. Now the next thing which I am going to plot in the diagram is the bearing of the star is given to us. The bearing is given as 285. So let's plot the bearing here in this rational horizon diagram. Now we know in this diagram the north point represents 0, 0, 0 bearing. Then going clockwise, the east point represents 0, 9, 0 bearing. The south point represents 180 bearing. The west point represents 270 bearing. And coming back to N, it represents 360, which is again equal to 0, 0, 0. So our bearing in this case, as given in the question, is 285. So let's plot this bearing. 285 would lie somewhere here. So from point Z, I draw the bearing line, basically the vertical circle passing through the body. So this should meet the rational horizon diagram at this particular point, since the bearing is 285. Now let's name this point as H. So Z to H is the vertical circle passing through the body and also represents the azimuth of the body, that is 285. Now the altitude of the star is also given to us. In this question, the sextant altitude is given as 35 degrees 10 minutes. The index error and height of eye is also given to us. So we can easily correct the sextant altitude and we can find out the true altitude of the star. So once we know the true altitude, which will be close to 35 degrees, we can now plot the star in our rational horizon diagram. Now on this line Z to H, if you see, H point is on the horizon. So on the horizon, the altitude is 0 and the Z point represents the zenith of the observer and the zenith represents 90 degrees altitude. So Z is at 90 degree altitude. This end of the line ZH represents 90 degree altitude and H represents 0 degree altitude. Now we have to represent or show 35 degrees altitude here. So from the horizon, I go towards the zenith, a distance equal to 35 degrees, which will be approximately 1/3 of this line. Close to 1/3, this total line is 90 degrees. So if we mark this true altitude here, we can show the celestial body in the diagram. The celestial body is always represented by alphabet X. So let's indicate the celestial body, the star, as X, and H to X, Hotel X-ray, represents the true altitude of the star. Now, if HX is the true altitude of the star, then the other part of this line, that is ZX, Z is the zenith and X is the celestial body or the star. ZX represents the true zenith distance of the star. Let me highlight it by using the green marker. So you can see on the diagram, ZX highlighted as green segment represents the true zenith distance of the star. You can also see that the true zenith distance and the true altitude added together always add up to 90 degrees. And that is what you can see in the diagram also. ZX plus XH or HX adds up to total 90 degrees, which can be considered as the radius of this rational horizon diagram. Beta, any doubt up to here?
No, sir.
Okay, great. Let's continue then. So we have the celestial body shown in the rational horizon diagram now. Now you see we have 3 points in our rational horizon diagram. We have the pole represented by P. We have the zenith of the observer represented by Z. And we have the celestial body represented by X. Now, two sides of the PZX triangle are also visible to us. ZX, the true zenith distance, highlighted in green, and PZ, which is the colat or 90 minus latitude of the observer, highlighted in yellow. So let's mark the third side of the triangle now. The third side is PX, and this side is represented by the celestial meridian of the star. So let's draw or plot the celestial meridian of the star in the diagram. So you can see, as shown by the laser pointer, we have the PX side representing the celestial meridian of the star. It is passing from the pole, and it is also passing from the celestial body. Now this celestial meridian cuts the equinoctial at this particular point. Let's name that point as D. So the point where the celestial meridian of the body cuts the equinoctial, we have marked that point as D. Now, concentrate your attention to the arc D to X, delta to X-ray. Now this delta to X-ray is the arc of the celestial meridian contained between the equinoctial and the center of the celestial body. This is the definition of declination. So D to X marks the declination of the body. In this case, the declination is north, northerly declination. So D to X, highlighted in the blue color now, represents the declination of the body. The arc of the celestial meridian contained between the equinoctial and the center of the celestial body is the declination of the body. Now we know D point is on the equinoctial and P point is the pole. Now pole to equinoctial, we know the arc of any celestial meridian from the pole to the equinoctial will always be 90 degrees. So Papa to delta, P to D is 90 degrees, and we are aware that delta to X-ray is the declination of the body. So P to D being 90 degrees and delta to X-ray being the declination of the body, now we know the arc P to X, Papa to X-ray, has to be 90 minus declination. So let's highlight it. I have highlighted it in the maroon color now, Papa to X-ray. It is equal to 90 minus declination, and this is what we call as polar distance. So P is the pole, X is the celestial body, and PX arc represents the polar distance. It is also the third side of our PZX triangle. So all the three sides of the triangle are now identified. Let's now move on to the angle Z of this triangle. Now angle Z of the triangle represents the quadrantal azimuth of the star. the bearing of the star is given to us. The bearing of the star is 285. So we know this arc or this line ZXH represents 285, and we know Z2N represents 360 or true north. So this angle is easily obtained as the difference between 360 and 285. So this comes out to be, in this particular case, for this particular question, it comes out to be 75 degrees. So this angle Z is the azimuth of the celestial body. Now in this triangle PZX, we have the PZX triangle in our rational horizon diagram now. Let's try to identify the parts which are known to us, about which the information is given to us in the question. You see the side Papa Zulu, PZ side of the triangle is 90 minus latitude. And you can see the DR latitude is given to us in the question. In this case, it is 30 degrees, 15 minutes north. So this side, Papa Zulu, PZ, is known to us. Let's put a green tick mark here. So indicating this side is known to us. Now, if you concentrate your attention to the green side, the ZX side of the triangle, it is the true Zener distance of the celestial body, and we know it is 90 minus true altitude. The question gives us the altitude of the star, though it's sextant altitude, but with index error and height of I, we can easily correct it and find the true altitude. So once true altitude is obtained, the TZD is also obtained as 90 minus true altitude of the body. So this side ZX of the PZX triangle is also known to us. And the azimuth we already discussed, this angle Z of the triangle, which is basically representing the quadrantal azimuth of the star, is also known to us. The three-figure notation azimuth is given to us as 285. Converted into the quadrantal notation, this gives you north 75 degrees west. So this angle Z, 75 degrees in this case, is also known to us. So we have the triangle PZX, which is a spherical triangle. It is made on the surface of a sphere. All three sides are great circle. PZ side is the celestial meridian of the observer. PX side is the celestial meridian passing through the body. All celestial meridians are great circles. And side ZX is the vertical circle passing through the body, which is again a great circle. So triangle PZX is a spherical triangle. And in this triangle, we know two sides, that is side PZ and side ZX, and the included angle, that is angle Z. So in a spherical triangle, two sides and the included angle is known. We are aware that we can apply the cosine formula and we can find out the missing parts. So we can easily apply the cosine formula using these known parts, and we will be able to calculate and find out the missing parts.
सर
बोलो बेटा।
सर अगर एजिमथ होता 270 से नीचे होता थोड़ा सा और वो इक्विनोक्शियल को कट कर रहा हो एंड बॉडी इक्विनोक्शियल के नीचे भी हो सकती थी, ऊपर भी हो सकती थी, बिकॉज हम वो तो चलो ऊपर है तो इसलिए हमें मतलब वो अंदाजे से इमेजिन करके मारा है कि वो इतना डिस्टेंस है, तो वहां से कैसे करेंगे सर?
ओके, so you are saying that the azimuth of the body is less than 270, right?
Yes, around सर 255 या 260 मान लो।
ठीक है बेटा, ठीक है। तो उसमें तुम्हें डाउट क्या आ रहा है कि बॉडी को कहाँ बनाए, इक्विनोक्शियल के ऊपर या नीचे? ये डाउट आ रहा है?
यस सर, वही डाउट।
ओके, ऑल राइट बेटा। बेटा, फॉर द पर्पस ऑफ मेकिंग द डायग्राम, you can make the body anywhere above the equinoctial or below the equinoctial. चाहे उसे आप नॉर्थ हेमिस्फीयर में दिखा दो चाहे साउथ में दिखा दो, डजंट मैटर एट ऑल.
बट सर वो पोलर डिस्टेंस चेंज हो जाएगा ना.
राइट, पोलर डिस्टेंस इज समथिंग बेटा विच वी आर फाइंडिंग आउट. जब हम कोसाइन फॉर्मूला अप्लाई करेंगे तो हमें पोलर
Yes, sir.
डिस्टेंस मिलेगा. So once we
ठीक है
get
सर.
the polar distance, then we will find out whether our diagram was right or wrong.
ठीक. ओके.
Okay?
ओके सर.
If
ओके.
समझ गया बेटा?
समझ गया सर, समझ गया बस.
Right. तो शुरू में आप, this is only a rough diagram, only for the diagram purpose. So once you make it, let us say you make it south of the equinoctial, and later on when you apply the cosine formula, you find out that polar distance was less than 90. So that tells you your initial diagram was wrong. Not an issue, no problem at all. The exact values are found after the calculation. The diagram which is made is only for the reference purpose. Okay, beta, understood?
Yes, sir.
Okay. Okay. Any more doubts up to here, beta?
सर ये ZQ कौन से केस में WZE के ऊपर होगा?
Okay. ZQ बेटा WZE के ऊपर होगा when you are in the southern hemisphere. When the latitude is south, you are in the southern hemisphere. So when you are in the southern hemisphere, the equator is north of you. So this tells us that when we are in the southern hemisphere, equinoctial has to be north of the zenith. Zenith represents the observer's position. Equinoctial represents the equator on the celestial sphere. So if you are in south hemisphere, the equinoctial will be north of the zenith.
ओके सर.
ओके. और बेटा और कोई डाउट्स अभी तक? ओके, ऑल राइट. अब बेटा आई थिंक द फर्दर प्रेजेंटेशन अगर हम इसको आगे शुरू करते हैं, it may take about 20-25 minutes. So I'm going to barge into your lunch time then. So you want me to continue now or you want to break off for lunch? I have the last lecture with you. We can finish it in the last lecture, whatever you wish.
Sir, finish it in the last.
सर बाद में करें.
Last,
Okay,
sir,
बेटा.
last.
ठीक है बेटा. फिर इतना याद रखना कि हमने ये PZX ट्रायंगल में 3 आइटम्स आइडेंटिफाई कर ली हैं एंड यहाँ से आगे फिर हम लास्ट लेक्चर में इसको शुरू करते हैं. सो देन यू कैन ब्रेक ऑफ फॉर लंच नाउ एंड वी विल कंटिन्यू दिस इन द लास्ट सेशन.
ओके सर.
सर एक डाउट था सर.
हाँ बोलो बेटा.
सर जो कल चार्टवर्क का क्वेश्चन डिस्कस किया था उसमें जब 3 पॉइंट बेरिंग बना के हमने इनिशियल पोजीशन फाइंड कर ली थी, उसके बाद सर उस क्वेश्चन में लीवे भी दिया हुआ है.
राइट.
10 डिग्री वो चलो प्लस माइनस होना जो भी है वो कैलकुलेट कर लेंगे. उसके बाद सर हम इफेक्टिव कोर्स प्लॉट करेंगे या जो हेडिंग दी होगी हमें?
ओके. अब बेटा आपको तीनों पोजीशन मिल गई हैं, आपको CMG भी पता है अपना.
करेक्ट सर.
राइट. आपको CTS भी दिया है उन्होंने.
करेक्ट सर.
आपको लीवे भी दिया है, विंड डायरेक्शन भी पता है.
यस सर.
अब मुझे ये बताओ कि जब हम चार्ट पे प्लॉट करते हैं तो हम लोग CTS को प्लॉट करते हैं या इफेक्टिव कोर्स को प्लॉट करते हैं?
हम तो इफेक्टिव कोर्स को प्लॉट करते हैं सर.
एग्जैक्टली बेटा. तो हम यहाँ पर भी इफेक्टिव कोर्स को ही चार्ट पे प्लॉट करेंगे.
हाँ सर वो ठीक है सर. उसमें क्वेश्चन में आगे फर्दर पार्ट था कि फाइंड करंट एंड रेट.
यस.
बट सर अगर इफेक्टिव कोर्स प्लॉट कर रहे हैं तो आफ्टर अप्लाइंग लीवे वी विल नॉट रीच DR पोजीशन आफ्टर सम पर्टिकुलर टाइम. सर अगर DR की डेफिनेशन देखें वो बोलता है कि विदाउट निग्लेक्टिंग विंड एंड करंट.
आई डिडंट अंडरस्टैंड यू बेटा.
सर उसमें अगर हमने इफेक्टिव कोर्स प्लॉट कर दिया उस क्वेश्चन में,
राइट.
फिर उसमें उसने सेकंड पार्ट पूछा था कि फाइंड करंट एंड रेट.
राइट, दैट्स राइट.
तो सर अगर लीवे लगा के जा रहे हैं तो हम डीआर पोजीशन पे नहीं पहुंचेंगे ना, और डीआर की डेफिनेशन के अकॉर्डिंग बोलता है कि उसमें डीआर पोजीशन में लीवे भी नहीं लगेगी ना करंट लगेगा।
ओके बेटा, फॉर द टाइम बीइंग फॉरगेट अबाउट द डीआर पोजीशन, भूल जाओ उसके बारे में, राइट? भूल गए?
ओके सर।
अब बेटा कंसंट्रेट करो, जो हमारा कोर्स मेड गुड होता है, कोर्स मेड गुड, it is the resultant of effective course and the set and rate of the current. Do you agree?
यस सर।
You agree ना?
यस सर।
ओके, अब बेटा इस क्वेश्चन में कोर्स मेड गुड हमारे पास है,
करेक्ट
हमने
सर।
फाइंड आउट कर लिया थ्री पॉइंट बियरिंग से। इस केस में इफेक्टिव कोर्स भी हमारे पास है, इंजन स्पीड, इंजन डिस्टेंस भी हमें पता है, राइट?
यस सर।
तो हमारी ट्रायंगल की दो साइड हमें पता चल गई। अगर हम ट्रायंगल की तीसरी साइड अपने चार्ट पे प्लॉट करते हैं, इट इज गोइंग टू स्ट्रेट अवे गिव अस द सेट एंड ड्रिफ्ट ऑफ द करंट।
नहीं सर, वो तो मैं एग्री कर रहा हूँ सर, बट सर वो पोजीशन हम डीआर पहुंचेंगे कि नहीं? डीआर तो बोलता है कि आप जो सेट एंड रेट है वो डीआर और फिक्स के बीच में होगा सर।
ओके, सो योर डाउट इज that after applying the wind and current,
नहीं सर, आफ्टर
after applying,
अप्लाइंग ओनली लीवे तो हम डीआर पोजीशन पे नहीं होंगे ना सर, जब होंगे सर?
why will not be on the DR position बेटा?
सर क्योंकि डीआर की डेफिनेशन अगर कहीं भी लिखी है, उनमें लिखा है ओनली जो हमें सीटीएस करेंगे और इंजन स्पीड, उसमें लीवे और करंट इंक्लूडेड नहीं है सर।
ये कहाँ है बेटा डेफिनेशन?
सर ये पूरी सर की बुक में भी है और सुधीर सर के में यही लिखा हुआ है सर।
ओके, just send me a screenshot. Let me see. Is it written in the day's work topic बेटा?
सर नॉर्मल डेफिनेशन और ईपी में लिखा है आफ्टर अलाउइंग लीवे एंड करंट।
ओके,
और डीआर में लिखा है विदाउट, मतलब कोई फैक्टर कंसीडर किए बिना नहीं, दोनों फैक्टर नहीं।
ओके, सो राइट नाउ एज फार एज द क्वेश्चन इज कंसर्न्ड, क्वेश्चन तो हम सॉल्व कर लेंगे, दैट इज नॉट एन इशू, राइट?
यस सर। यस सर।
क्वेश्चन सॉल्व हो गया। नाउ वी गेट स्टक ऑन द डेफिनेशन ऑफ द DR पोजीशन।
यस सर।
जो बुक्स में बेटा इन्होंने ये DR की डेफिनेशन लिखी है, इज इट गिवन अंडर द डेज वर्क टॉपिक?
सर अब देखना पड़ेगा, प्रॉपर्ली इतना याद नहीं सर।
जस्ट
देख के
लुक
बता
एट इट, जस्ट लुक एट इट।
सर डेज वर्क में ही है।
डेज वर्क में है बेटा?
हाँ जी जी सर।
ओके ओके, एंड दे व्हाट दे हैव मेंशन्ड देयर इज, तुम ऐसा करना बेटा, तुम मुझे उसका एक just take a picture of that from the book, just take a picture of that page where it is mentioned and send it to me. Let me see the context in which it is given.
ओके सर, मैं भेज दूंगा सर आपको।
ओके बेटा, ओके।
सर और एक चीज पूछनी थी, ये अपना ग्रेट सर्कल कंपोजिट सेलिंग में ना सर, अगर हम कोसाइन फार्मूले से अपना ए और बी की वैल्यू निकालते हैं, इनिशियल कोर्स और फाइनल कोर्स निकालते हैं कंपोजिट सेलिंग में, और साथ में अगर हम नेपियर रूल से निकालते हैं तो उसकी वैल्यू डिफरेंट आ रही है सर, बल्कि सेम आनी चाहिए ना इनिशियल कोर्स और फाइनल कोर्स की वैल्यू।
So you are finding the initial and final course using the cosine formula.
यस सर, उससे कर रहे हैं तो थोड़ा डिफरेंट आ रही है, और अगर हम नेपियर रूल से कर रहे हैं तो डिफरेंट आ रही है।
Just a minute बेटा, give me 1 minute. So एंगल A निकालना है तुमने। बेटा मुझे ये बताओ कि कोसाइन फॉर्मूला तुम कैसे अप्लाई कर रहे हो वहां पे?
सर पहले कॉस ऑफ पी यूज करके अपना ए बी की वैल्यू निकाल ली, और
So you
फिर
have found out AB using the Napier rule, correct?
करेक्ट। नो सर, ए बी की वैल्यू मैं पूरा उसको ग्रेट सर्कल ही मान के कर रहा हूँ।
ओह बेटा, यहाँ तो गड़बड़ हो जाएगी। सो यू आर सेइंग दैट आप A to B ग्रेट सर्कल कंसिडर करके एंगल A निकाल रहे हो
करेक्ट सर, उसको पूरा
कोसाइन
ग्रेट सर्कल
फॉर्मूला से, और फिर आप ट्रायंगल पापा अल्फा विक्टर 1 में नेपियर रूल से एंगल A निकाल रहे हो।
करेक्ट, दोनों की वैल्यू डिफरेंट आ रही है, ऐसा क्यों हो रहा है ये पूछना सर।
बेटा ये तो ऑब्वियसली डिफरेंट ही होगी ना। रीज़न इसका ये है कि जो ग्रेट सर्कल ट्रैक हम लोग कॉम्पोजिट सेलिंग में फॉलो करते हैं, that is not the same track which we follow in GC. जो GC वाला ट्रैक है उसका वर्टेक्स तो लिमिटिंग लैटिट्यूड से हायर होता है, और जो कॉम्पोजिट वाला ट्रैक है उसका वर्टेक्स लिमिटिंग लैटिट्यूड पे होता है. So how can angle A be the same? Because you are moving on different great circles.
Yes, sir. Understood, sir. Now, thank you, sir.
Okay, okay, बेटा. Okay, और बेटा और doubts? Okay, great. So, हाँ, बोलो जी.
सर जो मॉड्यूलर कोर्सेज के लिए अभी स्टार्ट किया है शेप में, उसमें सर 5 ईयर की वैलिडिटी दे रहे हैं, वो 5 दिन आना मैंडेटरी रहेगा क्या सर?
ओके बेटा, मॉड्यूलर कोर्स तुम संभाल के रखना. एंजॉय योर लंच फॉर नाउ एंड आई विल डिस्कस दिस इन द लास्ट सेशन.
ओके सर.
ओके, ऑल राइट.
Okay, sir. Thank you.
ओके बेटा, थैंक यू.